All right, let's dive into something I think is pretty incredible. We're going to talk about a huge leap forward in how we teach AI to look at a picture and figure out what actually matters. It's about giving AI a smarter, faster way to develop something that feels a lot like our own intuition.
Seriously, think about that for a second. You glance at a photo and boom, your brain just knows. It zeroes in on the main event. A person's smile, a splash of color, that one lonely boat on the water. We do this instantly, without even trying. But teaching a machine to have that same instinct? Well, that's been a massive, massive challenge.
So how does a cutting-edge AI handle this? It's not just making a wild guess, that's for sure. As you can see here, it actually talks itself through the problem, step by step. First, it gets the lay of the land, describing the whole scene. Then, it starts looking for clues, identifying the one thing that just pops, the most colorful, the most centered, the most detailed thing in the frame. And only then does it make its final call. This whole process is called saliency reasoning, and honestly, it's the key to everything we're about to talk about.
So here's the game plan for today. First, we're going to unpack the 3 big visual puzzles that AI has to solve. Then, we'll look at the old, kind of clumsy way we used to teach it. After that, we'll get to the main event, the big breakthrough. And of course, we'll show you the mind-blowing results and talk about what it all means for the future.
All right, let's jump into that first section, because it turns out teaching an AI to see isn't one single problem. Nope. It's more like a set of 3 different but totally related challenges. Think of them as 3 unique puzzles the AI has to get really, really good at.
And this is what those puzzles look like. First, you've got Salient Object Detection, or SOD. That's level 1. Just find the single most important thing in a picture. An orange and white kitten. Pretty straightforward. But then you level up to SIS, or Salient Instance Segmentation. This is trickier. Now the goal is to find every important object, like pointing out each and every golf club in a picture. And finally, you have the boss level, Co-SOD, or Co-salient Object Detection. Here, the AI has to look at a whole batch of photos and find the one common thread, the one object that appears in all of them.
So, you might be wondering, how did we used to train AI models for this stuff? Well, the go-to method was something called GRPO. And look, it was a solid first attempt, but it was just fundamentally clunky. Kind of like trying to teach a single student by just shouting general advice at an entire lecture hall and hoping for the best.
Yeah, this old way, GRPO, had some serious problems. First off, it was confidence agnostic. It just didn't care if the AI was already 99% sure it knew the answer. It wasted precious time and energy reinforcing things the AI already knew. Second, the learning signal got totally diluted. It's like that coach giving the same generic good job team feedback. Instead of pulling a player aside for specific advice, the lesson just gets watered down. And finally, the overhead was just brutal. It was a resource hog, demanding ridiculous amounts of computing power, memory, and time.
And this, my friends, is where our story gets its hero. Enter a brand new, beautifully simple training method called Confidence-Guided Policy Optimization, or, as we'll call it, CGPO. This is the game changer.
Just look at this comparison. It's night and day. The old way had to spit out a bunch of different answers and then average out the feedback. The new way, it only needs one. The feedback is no longer watered down. It's sharp, precise, and personal. But here's the most brilliant part. It stops wasting time on what the AI already knows and instead laser focuses on moments of surprise. This makes the whole process incredibly fast and lightweight.
So what's the secret sauce? It all comes down to this one simple idea, the reward-confidence discrepancy. All CGPO does is look at the gap between the actual score the AI got for its answer, that's the reward, and how sure it was that it was going to be right, that's the confidence. When there's a big gap between those two, when reality doesn't match expectation, that's a moment of surprise. That's the golden ticket for learning, and it's exactly where this new method puts all of its energy.
Okay, so the theory is elegant, it's smart, but does it actually work? Well, let's take a look at the results, because honestly, they're pretty spectacular.
This chart says it all right here. On the left, you see the weak little learning signals from the old method. It's like a gentle tap on the shoulder. Now look at the right. The signals from CGPO are twice as strong. It's like a clear, direct instruction. And it's because it's focused only on that critical 45.8% of examples, the ones where the AI was genuinely surprised, either because it was wrong when it thought it was right or right when it thought it was wrong. It just cuts out all the useless noise.
And what's the payoff for being so smart and focused? Oh, just a complete revolution in efficiency. These numbers are staggering. The new CGPO method gets better results
while using less than half the computing memory and doing it all in about a quarter of the time. We're talking about shrinking a training process that took over a week down to less than 2 days. That is a gigantic leap.
And now for the main event. This is the real mic drop moment. A brand new model called Saliency-R1 trained using this super efficient CGPO method, well, it doesn't just do well, it absolutely dominates, outperforming some of the biggest names in the game, like GPT-4o and Gemini. On these incredibly specific and difficult visual puzzles, a smaller, more intelligently trained model just flat out wins. It proves it's not about having the biggest model, it's about having the smartest train.
So, let's zoom out. A faster, better way to train one type of AI is cool for sure, but the ripple effects from this kind of breakthrough, they go way, way beyond just this one task.
If you're going to remember anything from this, remember these 4 things. 1. We now have a single model that can master 3 distinct and really hard visual puzzles at once. 2. This is proof that we can train powerful AI way more efficiently, saving a ton of time, money, and energy. 3. By focusing on surprise, we're making AI learn in a way that's much closer to how our own brains work. And 4. All of this leads to smaller, more agile models that can actually run circles around the big guys.
And that leaves us with one last big question to think about. For so long, we've just been teaching AI to recognize pixels and patterns. But now, we're teaching it to recognize importance, to understand what matters. And as this ability gets better and spreads to other areas, how is that going to change not just what AI can do for us, but maybe even how we see the world around us? It's an exciting future. Thanks for tuning in.